my name is Enrique Casco. We are Group 10. This is the Network Lab implementation. My group consists of TJ, Laurent, Madi, Casey, and German. Our scenario for the implementation includes the goal of this implementation is to create a working network. The network has some requirements. It must have 3 departments: A, which is 10 hosts, B with 60 hosts, and C with 200 hosts. The network must also include a file server and a database server. Finally, a remote office with 5 hosts. In addition, the network must have a minimum 3 routers, 3 switches, 2 servers, and 1 host. Finally, 3 switches must be connected to each other and at least 1 connected to a router. All the routers must be connected to each other as well.
This is our draft design. As you see, we have 3 routers here, router 1, 2, and 3, that they are connected together by their serial port and with serial cables. And router 2 is connected to the switch 3 with the trunk cable. As you see here, we have 3 switches. They are connected together via crossover cable, and these cables needs to be configured as a trunking mode in order to be able to actually transfer packets between VLANs 1, VLAN 2, VLAN 3, and other part of networks. As you see here, we have extra trunking port here between interfaces switch 1 and switch 2. We don't need this one in order to connect all 3 switches together, but we did it, and you might notice that when you have redundant path, like here we have 2 possible paths between any switch, so each switch automatically gonna turn on the spanning tree protocol on that, so it's gonna avoid switching loop over here. So if we didn't have this trunking port here, we wouldn't have to worry about spanning tree, but anyways, it's a auto configuration mode, so it's gonna be configured by itself. So on the switch 1, we have 2 VLANs. VLAN 1 between which is department A and database server on it, and the IP address as seen here is 192.168.1.11 until 192.168.1.20, and VLAN 2 consists of 60 hosts, is a department B, and as you see here, IP addresses start from 192.168.2.11 until .2.70, and as well VLAN 3 is on the 3rd subnet, and the IP addresses start from 192.168.3.10 for the file server, and we have 200 hosts on department C or VLAN 3 that you can see the IP address is configured here. As you see here, we have VLANs 1, VLAN 2, and VLAN 3 IP addresses assigned to it. These should be interface VLAN 1, interface VLAN 2, and interface VLAN 3. We don't need actually these IP addresses here in order to be able to make communication between VLANs and other part of networks, but this is useful when we are going to configure interface VLAN from a actually remote office or from a remote host. We need to have a interface VLAN IP address set up in order to be able to access to that VLAN to be configured, but we don't need right now to configure anything. We just need to create VLANs in each switches and make that ports to be accessed through those VLANs. As you see here, we need a minimum of 6 subnets. Subnet 1, which is VLAN 1 is on subnet 1, subnet 2, VLAN 2 is on subnet 2, and VLAN 3, subnet 3 is on actually VLAN 3 is on subnet 3, and subnet 4, 5, and 6. Subnet 4, as you see, connecting our main router to the router that is going to be connected to the ISP and to the public network, and subnet 5 is connecting the main router to the first router, which is connecting to the remote office, which has 5 hosts on it, and remote office is on the subnet number 6 here. We prefer to use the actually single subnet mask in this for this project, because that would be enough, and it would give us enough IP addresses even for class C, which has 200 hosts, and for other classes if we want to update our network. The most important part here is the main router here, which needs to route between 3 VLANs. So we need to configure sub interfaces on this actually gigabit Ethernet port, and we have a sub interface 0/0.1, which is, as we're gonna encapsulate it to be accessed by VLAN 1 and route information and packet from VLAN 1 to the other part of the networks. Same as for VLAN 2, we have to configure the subinterface 0/0.2 and 3 as well. So if you see these IP addresses, these are IP addresses of the sub interface for the main router. Therefore, every host on VLAN 1 gonna have a default gateway address of subinterface 0/0.1. So 192.168.1.1 is going to be the default gateway address of every host on VLAN 1, and 192.168.2.1 is going to be the default gateway address of every host on VLAN 2, and for VLAN 3 this subinterface IP address is going to be the default gateway for every host on VLAN 3. As you see here, we need to configure the clock rate and different IP addresses for different interfaces of the main router. So we have 3 interfaces, 2 of them are serial port that they are connected to the subnet 5 and subnet 4, and this router is connected to the subnet 6 and subnet 5. We could implement actually routing protocol here, or using different technologies, but we're just using the serial cables in order to connect our routers. In this case, we need to configure default route on every router that can communicate with the networking that they are not directly connected to them. For example, if you see here, this network is not directly connected to this router. So this router doesn't have any idea about this network until it has a actually default route on it. So it could transfer packet through this interface to this network that doesn't have any idea about it. So we could configure a routing protocol like OSPF or EI group or other routing protocol, but or ISIS, intermediate state, but we're just using the default IP route for the routers that in order to be able to communicate with the networks that they are not directly connected to them. And we're gonna see that this router, we're gonna configure it as a NAT router, and we're gonna configure this interface as a inside NAT and this interface as an outside NAT inside of the network, and this one's gonna be outside of the network. And then I'm gonna show you the simulation that we can ping from any host here to the public network, or public to any other host, or any other host on the VLANs 1 to the other VLANs. Here is just showing you the physical connection on the routers that it was on the picture slides before this. Just shows you the DT side and DC side of the routers and Ethernet port to the remote office for each router here. And Yes, you've seen these actually configuration on the pictures before this slide. These are physical showing physical connections of switching. As you see here, switch 1, every switch that connect to other switch it has to be via trunk port, because the trunk port carries all the VLANs and can see all the VLANs. And switch 2, same thing on these VLANs, and if you see it on the other ports like GI0/3, it's just connected to the VLAN 3, and this port is not gonna be a trunk port. It just carries all the packets from VLAN 3 or to the VLAN 3. And switch 3 is all of the ports to the switch 3 is a trunking port, because all of the other VLANs gonna communicate to the main router via the main switch or the third switch that connected to the other two switches.
Now we're creating VLANs and assigning IP addresses. The subnet mask for the entire network, we used 255.255.255.0. VLAN 1 includes Department A and Database Server. VLAN 2 includes Department B. VLAN 3 includes Department C and File Server. For switch 1, we used VLAN 1 on subnet 192.168.1.0. Department A IP addresses 192.168.1.11 through 192.168.1.20. The file server IP address was 192.168.1.10. And the default gateway for every host will be 192.168.1.1. The VLAN 2 on subnet 192.168.2.0 and the Department B IP address were 192.168.2.11 through 192.168.2.70. And the default gateway for every host will be 192.168.2.1. We also created a VLAN 3 and continue on to VLANs and IP addresses. The subnet mask for the entire network 2.55.255.255.0. For switch 2, VLAN 1 and 2 are default. VLAN 3 on subnet 192.168.3.0. The Department C IP addresses 192.168.3.11 through 192.168.3.2.110. The database server IP address is 192.168.3.10, and the default gateway for every host would be 192.168.3.1. We also created VLAN 2. For switch 3, we create VLAN 1, 2, and 3. Remote office on subnet 192.168.6.0 included IP address 192.168.6.11 and 192.168.6.15. And the host on ISP, the public IP address, was 130.74.8.11 and subnet 255.255.255.0. So after we showed you the physical implementation and also the VLANs and IP addresses, we'll move on to the configuration on the switches. For switch 1, for interface range GI01 through GI02, we did a no-shut, switch port mode access, and switch port access VLAN 1 to create the VLAN 1 on switch 1. And then we moved on to interface GI03, again no-shut, switch port mode access, and switch port access VLAN 2 to make VLAN 2 on switch 1. And then we moved on to interface range GI04 through GI05, again no shut, switch port mode access trunk, and switch port trunk allowed VLAN 1, 2, and 3. This is to allow trunking. To continue configuration onto switch 2, we did interface range GI03 to GI04 on switch 2. Again, we did a no shut on this switch, and then switch port mode access. Switch port mode access switchport access VLAN 3 to create VLAN 3 on switch 2. And we move on to interface range GI01 through GI02. Again, a no-shut switchboard mode trunk. Switchboard trunk allowed VLAN 1, 2, and 3 to allow trunking from switch 2 for all of the VLANs. And finally, switch 3, we did an interface range GI01 through GI03, allowing no shut, and we did the trunk, switchboard mode trunk to allow trunking, and allow trunking through VLANs 1, 2, and 3. And so now we moved on to configuring the routers. Configuring router 2, we had to configure the interface GI00 on router 2. First we did a no shut, and we did an interface and worked on interface GI0/0.1, and we allow encapsulation with .1Q1, assigning IP address 192.168.1.1 in subnet 255.255.255.0. And moving on to interface GI0/0.2, again allow encapsulation .1Q2. And for this, the IP address is 192.168.2.1. And again, the subnet is the same as before, 255.255.255.0. And finally, interface GI0/0.3 allow the encapsulation for .1Q3. And this time the IP address is 192.168.3.1 with subnet the same again with 255.255.255.0. And we allow IP routing to through all zeros and serial port 00. And then again another IP routing with all zeros for the IP address and for the subnet, and through serial port 0/1.
So now we're continuing the configuration. For router 2, the interface port for that, we used serial port 0-0, and we did a no shut, and the IP address for that was 192.168.5.1, and the subnet mask was 255.255.255.0, and then we assigned a clock rate of 64,000 for that one. And then for interface, for the second interface, we did serial port 01, and we did a no shut on that, and the IP address was 192.168.4.1, and the subnet was 255.255.255.0. The clock rate was also 64,000. So for router 1, the interface, for that we used serial port 00, and we did a no-shut command on that. And then we assigned the IP address 192.168.5.2, and then we assigned a subnet of 255.255.255.0, and then we did for the interface GI0-0, we did a no shut and assigned an IP address of 192.168.6.1, and then gave it a subnet of 255.255.255.0. And the IP route, we did all zeros, so it goes through, and then the serial port for that was 0-0.
The configuration of router 3 included a serial port of 00 and an Ethernet port of also 00. Both interfaces utilize the no-shut command, being entered before the IP addresses are configured. We set the IP of the serial port to 192.168.4.2 with a subnet mask of 255.255.255.0. As for the Ethernet port, the IP was set to 130.74.0.0.0 255.5.1 with also a subnet mask of 255.255.255.0. We use the IP root command of 0000 on the serial port 0/0 to communicate between the two networks. During the actual implementation of the network design, we came across several different problems, with the amount of time given being the main issue. With insufficient time, we were not able to configure the remote host and router 3 to the internet correctly. During the configurations of each interface, we used incorrect commands at first, slowing us down greatly when we had to go back and correct them. Before we started the implementation, we manually reset each router and switch to avoid confusion from the other lab sections. When entering commands for one of the switches, we found out that the reset didn't successfully complete, so we had to go back and repeat this step, slowing us down even greater.
Here, this is our configuration for router 3 as a NAT router. On router 3, you see I wrote it down in different color, the command that is required to actually configure one router as a NAT. Here you see the IP NAT inside this interface, that's for inside network. We need to configure it out, and this interface gigabit Ethernet, we configured as a NAT outside, so it could transfer our packet from the network to outside and to the public network, and this interface enables the public network to be access our network. However, we need to configure two other lines. Here we do the access list permit IP address from any source address to any destination address. This is gonna configure in the whole router, and the IP NAT inside source enabled through the serial port 00. Now I'm gonna show you about pinging and some test ping we have through our VLANs and remote office, and also host on ISP. On VLAN 1, we go and we're gonna ping VLAN 2. It's gonna take a while, gives it a timeout, and then you see the success ping. Let's ping VLAN 3 file server, and we get response right away. Remote office 6.11. And let's ping from ISP and public host to one of our VLANs. Ping 192.168.1.11. So you see the pinging is successful, and through the remote office also pinging is successful.
Overall, we had some successful pings that went across segments of the network, but not all. Also, because we did not have the time to configure the remote router side, that part was not tested. Nevertheless, we were able to establish some connections and do some pings. If we had even a few more minutes, we would have been able to fully establish a working network.